This lesson covers translating algebraic expressions. What is an algebraic expression? It's a collection of variables and numbers combined by arithmetic operations, so multiplication, division, addition, subtraction, etc. Here are some examples. That's an algebraic expression. There's another one. And there's another one. Some key words that we can start off with in order to be able to translate some phrases here. You almost want to pause the video and just take some notes off of these. These are all really good words. You can ask me for a handout of this if you'd like. But really make note of the key ones that you end up noticing in your questions a lot, and that'll help you out. So a few things to mention about the following keywords. These ones here, I've bolded them: less than and subtracted from. Very important. They signify a different order of translation. So all the other words, you would read them left to right, and they would mean the following: addition, subtraction, multiplication, and division. However, less than and subtracted from are the only phrases that are not read left to right. Meaning, if you had 2 less than 5, that would actually mean 5 minus 2. However, if you had 2 less 5, that's like saying 2 less by 5. That's still in the same order. So specifically less than and subtracted from oppose the order, so you actually take the second part and then subtract the first part. The other thing to note is that if you have blank of in a statement, this of doesn't always mean times, as it says here. Sometimes if it says the sum of blank and blank, you would take blank and then the sum of. The sum is actually the word that implies the and there. So blank plus blank. Now, if you erase that, the sum, and make that a product, the product of blank and blank, that would mean that the and means the times. Same thing for if it said quotient, it would mean division. So sum, product, quotient, or difference. If it's a difference, it would be a minus. So you can see how some of those words, they change their meaning if they're beside other words. For the most part, these words work. So let's try some examples. That's probably the best way to really get the hang of this. Okay, here's some examples. Translate the following phrases. Half of the population. So here, they're not telling you X, they're not telling you H. So another important thing with these translating examples is first, always define your variables. You want to know what your variables mean. So in this case, they want population to be a variable. So I would say let P equal population. So then the phrase would be half of, and of in this case means times, as in the keywords, half of the population. Half of the population. This could also be written as P over 2, because taking half, meaning multiplying by a half, is the same as dividing by 2. Next, 5 less than the height. So here our variable is the height. So let H equal height. And then now we have this special less than, which means we have to reorder our phrases. So we want to start with the second phrase, the height, and subtract 5 from it because 5 is less than the height. Next, 10 divided by the square of a number. So this we can read left to right. There's no phrase changing here, order changing. So we've got 10 divided by the square of a number. So the square of a number, we need to define that. So we gotta let x equal number. So if x is our number, the square of the number is x squared. So 10 divided by x squared can also be written in this way. And there we go. Some more examples. Getting longer here. The product of two consecutive numbers decreased by 1. So this is an example where this of is kind of linked to the product, and in this case product means times. So we're taking the product of two numbers and two numbers that are consecutive. So let's just map that out here. So we're going to take a number times another number. That's the product of two numbers decreased by, it's not less than, so it's the same order, decreased by 1. Now we need to define our variable. Let x be, say, the first number. So if they are consecutive numbers, consecutive means one after the other, or following each other. So if x is the first number, how would we define the second number? Well, if you think of the number line, if you go from 1 to 2 to 3 to 4, how do you get from one number to the next? You add 1. So you got x plus 1 is the second number. So we want to take the first number times the next consecutive number is going to be the product of two consecutive numbers. Right there. It's decreased by 1. So a little more elegant way of writing that is x times x plus 1 minus 1. Next example, twice the sum of the square of a number and 1. So you want to go twice, 2 times the sum of. Now this opens up that phrase that I was talking about. The sum of blank and blank. So in this case, the sum, that word, the plus sign, is going to be where the and is. This is just 1. Now we need to find a way to represent the square of a number. So we need to let our x be the number. That's our variable. And they want the square of the number inputted here. And all of this needs to be doubled. Right? So it's twice the whole thing. See, if it said twice the square of a number and 1, it would mean a different thing. So be careful of the order. If it says twice the sum of, you almost want to go 2 times bracket with a plus. You know that you're doubling the entire sum of two things. And now those two things are, one of them is the square of a number, one of them's 1. Next example, the square of the difference between a number and 1. So here they're saying the square of the difference. So you almost want to set yourself up. We're going to let x be the number. And now we're taking the squaring a whole thing that has two things that are minused in between, implied by the word difference. And what are those two things that we are finding the difference between? The difference is found between a number and, difference is right there, and 1. So a number and 1.